Hi guys, today our lesson is on compound probability. A compound event is an event that consists of two or more actions. To find the probability of compound events, you multiply the probability of each of the events. Let's review the type of events. Independent events are events where the outcome of one event does not affect the outcome of the other events that follow it. Dependent events, on the other hand, are events where the outcome of one event depends on the outcome of another event. So let's take a look at some examples and determine whether we have an independent or dependent event. You flip a coin and then roll a fair six-sided dice. These are two separate events, so these are considered independent events. The second one, a bag contains 8 red marbles, 4 blue marbles, and you randomly pick a marble and then pick a second marble without returning the marbles to the bag. When you don't return a marble, it is definitely a dependent event, because after you have selected one and you keep it out of the bag and then select another, every choice you make after that first one is dependent on what you chose the first time. So make sure you look out for this wording, without returning the marbles to the bag. That means it's a dependent event. The third one, a box of chocolates contains 5 milk chocolates, 5 dark chocolates, and 5 white chocolates. You randomly select and you eat 3 chocolates. Well, once you have selected a chocolate and then you eat it, it is no longer available. So this would be an example of a dependent event. Draw a card from the deck and you put it back, then you draw another card. This is an independent event because you replaced the card back in the deck. So all 52 cards are still available to choose from. So that is independent. Let's take a look at some examples where we're actually calculating the probability. You definitely want to have your calculator handy, as we will be recording it as a fraction, decimal, and a percent. Example 1, you roll a single die numbered 1 to 6 twice. What is the probability of rolling a 6 the first time and then an odd number the second time? Okay, so let's record the probability. P stands for probability. On our first roll, we want to get a 6, and on our second roll, we would like to get an odd number. Okay, so these are two separate rolls of the dice. One does not depend on the other, so this is considered an independent event. So the probability of getting a 6 on a die, that's 1 out of 6. We're going to multiply that times the probability of our second event, which is we want to get an odd number on our second roll. So on that second roll, we still have a die that has 6 numbers. However, there are only 3 odd numbers on that die. Those numbers include 1, 3, and 5. So when we only have 3 out of the 6, we're going to record that as 3, 6. And now we're going to just multiply straight across. So 1 times 3 is 3, 6 times 6 is 36. Now when you have a fraction and you can reduce that fraction, you should always simplify it to lowest terms, and that does simplify to 1/12. If you're unsure how to simplify the fraction, you can always enter it in your calculator by entering 3, pressing ABC, pressing 36, and hitting the equal button, and you should see 1/12 appear. So this is our probability written as a fraction. To turn it into the equivalent decimal, you just divide. You're going to divide 1 by 12. So when you do that on your calculator, you should get 0.083. Now we have the probability as a decimal. To convert that to the equivalent percent, All you do is move that decimal 2 places to the right and add that percent symbol. So it's 8.3%. So there's our 3 different ways we could record our probability. 1/12, 0.083 or 83 thousandths, or 8.3%. Let's take a look at the second example. There are 8 shirts in your closet. We have 4 blue shirts and 4 green shirts. You randomly select one to wear on Monday and then a different one on Tuesday. What is the probability you wear a blue shirt on both days? Well, this is a dependent event because after we've made the first choice on Monday, we have a second choice to make on Tuesday. So let's record the probability that we choose a blue shirt on Monday and then also a blue shirt on Tuesday. The reason why they're dependent is because we need to choose a different shirt on the second day. So let's record the probability. We have 4 blue to choose and 4 green to choose. So we have 4 different shirts to choose from on Monday out of the 8 total shirts. We're going to multiply that times what we have on Tuesday to choose. Now, once you wear a shirt on Monday, it is no longer available on Tuesday. So if I take 4 and I subtract 3, or subtract the one that I wore on Monday, that would mean I would only have 3 blue shirts to choose from on Tuesday and 7 overall. So let's talk about that again. The probability of wearing a blue shirt on Monday, another blue shirt on Tuesday. I have 4 blue shirts to choose from on Monday out of 8 shirts. But on Tuesday, because I wore a blue shirt on Monday, I now only have 3 blue shirts to choose from out of a total of 7 shirts. Multiplying straight across, 4 times 3 is 12, 8 times 7 is 56. I can still reduce this fraction to 3/14, and now it's in lowest terms. So there's my probability of wearing a blue shirt on Monday and a blue shirt on Tuesday, 3/14. To turn that into the equivalent decimal, I just divide 3 by 14, and when I do that, I get 0.214 or 214 thousandths. If I want to turn it into the equivalent percent, I'm just going to move that decimal 2 places to the right, and it will be 21.4%. So there's the 3 different ways that you could write this probability. Let's take a look at 2 more examples. A basket contains 5 apples and 7 peaches. You randomly select one piece of fruit and eat it. Then you randomly select another piece of fruit. What is the probability that you select an apple and then a peach? This is going to be a dependent event because after we selected a piece of fruit, we actually ate it and it was no longer available. So we are looking for the probability of choosing an apple first and then a peach. So the probability of selecting an apple, it looks like we have 5 apples out of 5 plus 7 is 12 pieces of fruit times, since we want a peach on our second choice, we have 7 peaches available. But because we ate 1 piece of fruit after the first choice, we only have 11 pieces in total to choose from. Multiplying straight across, we get 35 over 132, and that fraction is in lowest terms. To convert it to the equivalent decimal, simply divide the numerator, 35, by the denominator, 132, and that would be 0.265. Moving the decimal over 2 places to the right to get the equivalent percentage would be 26.5%. In the last example, a drawer contains 12 blue pens and 4 red pens. Without looking, the teacher takes a pen from the drawer, uses it, but she puts it back in the drawer. Then she takes another pen out of the drawer and uses it. What is the probability she takes a red pen and then a blue pen? So this is going to be an independent event since the teacher is putting the pen back and then drawing again. So the probability of getting a red on the first draw and then a blue on the second. So our probability, we have 4 red pens, because remember we want to get a red on the first draw, and we have a total of 16 pens in the drawer. 12 plus 4 is 16. Times the second draw of what's available of blue pens only, that's 12 out of the 16. Multiplying straight across, we get 48. 4 times 12 is 48. And then 16 times 16 is 256. That fraction can be reduced to lowest terms, and that is 3/16. Again, use your calculator and the ABC button to help you reduce quickly. To turn that into the equivalent decimal, remember you're going to divide the numerator 3 by the denominator 16, and that would equal 0.1875. For the equivalent percentage, just move it 2 places to the right, and the percent will be 18.75%. Okay, there you have it, our lesson on compound probability. Make sure that you decide whether it's an independent or dependent event first, and then you can go ahead and find your probability using multiplication.